Is our exam really this Thursday?
Was that a question to me? No.
Yes, sir.
Oh, what was it?
Is our exam this Thursday?
We're going to talk about that.
Okay. Thank you.
Just wait another 30 seconds here. Let people get in. Okay, let's go ahead and get started. So yeah, the first order of business here, let me start recording. Oh, I am recording, okay. First order of business here is the exam that is scheduled for Thursday. So my intention would be to cover on that exam 35364755. So we can postpone the exam and have it on Tuesday. I have no problem with that. But if we do that, we're going to have to include 6.1 on that, which is integration by parts. At least part of it. I don't think we'll be able to do all of it, but at least the basic idea of integration by parts. So maybe I can just get a feel for how you feel as a class. So I'm going to just send out a poll real quick. So yes would mean you want to keep the exam for Thursday covering just through 5.5. No would be let's push it till Tuesday the 15th and have it cover up through part of 6.1. So yes, keep it as is. No, move it one class period.
Will we be doing 6.1 in exam 2?
That if we keep the exam on Thursday, 6.1 will be on exam 2.
Okay.
Well, any other votes on that?
Sir, can you repeat the question? Sorry, I just came in.
Okay, yeah, so the exam is scheduled for Thursday. We can keep it for Thursday, but it will only cover up through 5.5, which is substitution, which we started last class. We can also move it till to Tuesday, the 25th, September 15th, but then it will have to include part of 6.1. So yes is keep it, keep the exam one for this Thursday. No is let's move it to next week, a week from today. Oh man. All right, well, that doesn't help. So here's the results. So we're like 50-50 here pretty much for moving it, keeping it. Why don't we re-examine this? Let's get through today's class, okay? And then what we'll do is we'll see how you feel with 5.5. We're gonna start talking about 6.1 today. So after you see 6.1, maybe you'll say, you know what, yeah, I'd like to see that on the test, in 48 hours, or you know what, no, let's just save that. Now, historically speaking, exam 1 is usually the easiest exam out of all of them, all right? Because we're having it, this is the 3rd week? Is that correct? Are we in week 3?
Yes.
Yeah, we're in week 3. So we're having our first exam in the 3rd week, which is pretty soon. So it doesn't cover a whole lot of material, and the material is not that difficult. So it's, you know, you might want 6.1 on this test just to make the next test not as difficult. But let's go through today. Let's see how the material goes. Okay, and we'll do another poll at the end. All right, so let's get going with today's stuff. So we started talking about substitution last time, and the whole idea, you know, I just gave you a couple of notes here. I know it's really small, but we talked about it last time. What you can do is you're going to look at the integral, you look at the integrand, you try and find something, and then hope to see that derivative of that something there. Make sure that the derivative isn't trapped or in the denominator or anything. Make sure it's in the numerator only. It's okay if that derivative is off by a constant, and then you make a substitution. U is equal to that something that you saw. And that's it. Those are my notes. But I wanted to show you, like, mathematically why we're doing what we're doing. So let's just start off here. Let's say you have a function. Y is some function, capital F of g of x. So what we have here is composition, all right? So let's say we have composition of two functions, capital G with little f. Then if we're asked to take the derivative of this with respect to x, we have to use the chain rule. So the chain rule would say, first you take derivative of capital F, which is little f, and then you just plug G into that. You don't do anything to G. And then you multiply that by the derivative of what's on the inside, which is G prime of x. So that's from Cal 1. That's our chain rule. That look familiar?
Yes.
Okay. So just be careful with the notation. I'm using capital F, and instead of using capital F prime right there, I'm just using little f. Okay, so now this next step from here to here, all I'm doing is multiplying both sides by dx. So that way it appears over here on this side. Now, if we want to now take the antiderivative of this, we take the antiderivative of the left side. And the antiderivative of dy, that's really like a 1 right here. So the antiderivative of that should just be y. The antiderivative of 1 with respect to y should just be y. But let's take a look at the right-hand side. What we're doing is we are calling this piece in here u. So that's the something that we're looking for in the integrand. And then we're trying to identify the derivative of that something. Also, we're trying to identify both those pieces. And then what we do is we make the substitution. We let u be that something. So u is that g of x. And then du should turn out to be everything else, the g prime of x dx. And if you do that and rewrite the integral, then this g of x gets replaced with u, and that entire thing gets replaced with du. And now you're looking at a function, you're just looking for the antiderivative of little f with respect to u now instead of x. So all it does is simplifies the work, because at the very end you're looking at a basic function instead of this function with something in it and a derivative sitting on the outside. So I don't want you to get too like, I need to know this. I'm just, for those of you who are skeptical on like why this works, this is the actual idea here. So what I'm going to do, and I hadn't really planned this until earlier today, I was like, okay, I've done all the homework problems right out of the section 5.5. I've done them all on video. Let me see if I can do some other substitution problems. So I just went online and I just Googled, you know, U substitution, and got a set of problems off the internet that I've never done. So I thought it would be a good, you know, kind of example. I'm going to do some problems that I've never seen before. I'm going to use U substitution, and let's just see how it goes, okay?
Okay.
So here we go. So the first problem here is to integrate this expression here. So what I think I'll do, I want to, you know, I'll just copy this and bring it to a new page. Why is that not working? really weird. Let me try this again. For some reason, my little screen snipper is not working. There we go. Okay, so we're going to take this problem 1. Let's take that over to a new page and work this out. I hope that's coming out clear enough. Okay, so one little asterisk here is, and this is something you need to think about as we move ahead. Right now, the only technique of integrating that we have is U substitution, right? So when we look at this, once we convince ourselves that this is not some basic thing like power rule or some formula from Cal 1, as soon as we kind of eliminate those as possibilities, the only other thing we have is U substitution, right? So think about this next test that you're going to be taking either on Thursday or next Tuesday. If you do it on Thursday, then you know with the integrals that the most I'm going to ask is U substitution, right? If you wait till Tuesday, then there's going to be U substitution or integration by parts, and I'm not going to tell you which method to use. And so you actually have to like figure that out. And then when we get to exam 2, you're going to have all 5 techniques. And so when you look at them, you don't know which one to use. And that's what makes the next exam, exam 2, that's what makes it hard, is that you don't know what method that you're supposed to employ. Does that make sense? So it's just really practice, 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 where you get to this point where you're like, you look at it, you're like, oh yeah, I'm going to do this, you know, whatever it is. Okay, so I know this is U substitution, all right? So that's kind of cheating already, but let's just go with this. So do I see something and its derivative? Well, I see x squared plus 5x, and the derivative of that is 2x plus 5, which I see right here. And I'm even going to highlight the dx because that's part of the derivative. So this is the first problem. So it's kind of straightforward. I'm going to let u be the x squared plus 5x. The du, derivative of u with respect to x, will be 2x plus 5. I'm going to multiply both sides of the equation by dx. So I'll put the 2x plus 5 in parentheses. And now everything just matches perfectly. I mean, this is about as easy as it gets. That matches, and that matches. So now all I have to do is rewrite the integral. So I'm going to rewrite the integral and say, okay, this is now, let's see, everything in green is going to be replaced with du. Do you all agree with that? Everything in green is going to be du. So I'm just going to slap that at the end here. And then everything in yellow gets replaced with what?
With U.
U, right? And I still have that 7th power. Let's not forget I have a 7th power there. So that's just going to be u to the 7th power. And you see now this integral is much easier to work with. This is just going to be a power rule, right? Just going to use the power rule for u to the power n. And so the antiderivative of this should just be 1/8 u to the 8th plus c. That's just my power rule. And then last step is to replace.
I have a question.
Yes.
How do you integrate the values for u and du? Like, I'm having a hard time understanding.
How did I integrate what?
The values for u and du over x and du, like right by the right side.
Oh, over here on the right? What did I do over here?
Yes, sir.
I just took the derivative. So I took this in red, right? And I just took the derivative of each one, right? Derivative of x squared is 2x, derivative of 5x is 5.
No, what I mean is, how did you equate, like, decide that u is x squared plus 5x?
Oh, like why did I choose that u was going to be? Because I realized that if this is u, then that is the derivative of it. So this right here, that's that something that I'm looking for. I was looking for something, right? And I was looking, this was going to be the derivative of the something. Does that make sense?
Yes, I understand because the x squared plus 5x, you take the derivative, you get the 2x plus 5.
That's
So,
right.
yeah, okay.
Okay. So now this problem was, again, very straightforward because it was right there. Like there's u, there's its derivative, everything is perfect. It works out great. I'm imagining that these problems are going to get harder. So let's see.
What happened? Wait, what happened to the du in the second problem?
Okay, so this is a common question. Remember, this and this right here are just part of the notation
Mm-hmm.
that we use to tell you that we want to take the antiderivative. This is really the function you're trying to find the antiderivative of.
Okay.
So if I just ask you, what's the antiderivative of u to the 7th with respect to u, you're going to tell me 1/8 u to the 8th.
Mm-hmm.
And then the plus c is because every time you take an antiderivative, you always have to have a constant.
Mm-hmm.
So people always ask, like, what happened to this, right? Like, where did this go? Where did this go? It doesn't really go anywhere. It's just keeping track of your variable. And so this is the part that you're really working with. I hope that we had a discussion at the end of class with some students about this. This is kind of a weird thing to explain, but some people and some students in the past have done better if I just explain it this way, even though it's not correct, okay? If you want this du to go somewhere, then make it the plus c, okay? Like if you need it to go, if you need to be like, what happens to the du, then just make it the plus c so you don't forget it. Technically, that's not what's happening, but if it helps you remember the plus c, then good.
Okay, for sure.
Okay?
Yep.
Okay, let's take a look at the next one. All right, so for this one, so when you look at this one initially, you're like, well, maybe you're, I don't know what you were like. I'm like, it's not a very complicated expression. The only thing that's really the bad thing there is that 10th power, right? Like if that were just 3 minus x, it would be there would be nothing to do here. But because there's a 10th power, I really don't have any hope of doing this. I can't just apply the 10th power to each one, right? That's a big no-no. You can't just like distribute the 10th power to each one. You could expand this, like you could do that if you wanted to, if you were the type of person that had enough time in your life to sit here and multiply this out 10
On a
times.
test.
Yeah, you would never want to do that, right? Never, ever want to do it. And then plus, what if they make that 100, that power the 100th power? You know, it's like at some point you would submit, right? So that can't possibly be the way we're going to do it, right? Somehow this is a substitution. So I'm going to ask myself, do I see something and its derivative? And the something that I see, and this may not be very like evident initially, the something that I see is actually the 3 minus x. Because the derivative of, what would the derivative of that be? Du dx would be what?
10 to the 3 minus x something?
Now, what's the derivative of the u that I've chosen?
-1.
Is
One.
negative
-1.
Never.
Okay, so -1. And I'm going to multiply both sides by dx. So let me ask you, do you see, oh, let's highlight it. We have a 3 minus x, right? So that's going to be u. Do you see a -1 dx? So do you see this anywhere?
No, but we can make it negative.
Yeah, see this right here, we have dx, don't we? But we don't have a -1, right? So, but that's easy to fix. And this is where I said in the notes here on the side, step number 4 on the notes, you can be off by a constant. It's okay, we're off by -1. So all I'm gonna do is on this equation here, I'm gonna just multiply both sides by -1. Okay, so I get negative du is equal to dx. And now this dx matches exactly with that. And this right here matches with that. And so I should be able to rewrite the integral now. So let's see, I'm gonna go off my list here today. Brian Vasquez is up. Brian, what would my new integral be? Is Brian here?
Yes, sir, I'm right here.
Okay, there
would
you
it,
are. Yep.
would it be u to the 10th?
U to the 10th, good. And then what are you gonna replace dx with?
Would it be plus c?
du.
Oh, yes,
Yep.
du.
Negative du, right? Negative du, right? So watch what I do here. I'm going to cheat here a little bit. I have a negative, right? I'm going to put the negative on the outside of the integral. And if you want, you can look at it as a -1 times. And that's because when you're taking derivatives, right? If you have constants in front, they come for the right. And we said last class, if you're doing antiderivatives and you have constants, they come for the right also. So I'm taking that negative out, and I'm just going to put du there. That makes sense, Brian?
Yes,
Yep.
sir.
Okay. So now at this point, we can just employ the power rule, right? The antiderivative of u to the 10th power. That's what we're really focusing our attention on. And Brian, what do you have for that? Have you gotten to a comfort level yet with power rule?
Would it be 1 over 11 u to the 11th
Uh-huh. And then
plus c?
let's see, there we go. Okay. And then what we can do is maybe clean up that fraction, make it -1/11. And then we do need to replace u back with 3 minus x to the 11th power and then plus c. And that's it. So that's an example where the u that we picked wasn't really complicated. It was just 3 minus x. It spit out a -1, which we were able to address by just multiplying both sides of that equation by -1. And then everything just seems to kind of work out nicely. Now, remember, you can always check your answers, right? That's one good thing about antiderivatives. You can always check them. So if I take the derivative of this, I better get back, right? If I take the derivative of this, I better get back this. Well, not the dx, just this part. So we could do that, right? If we took derivative of this, you would do chain rule. So the 11 would come out first and hit that -1/11. So that would give you -1 times 3 minus x. The power came down, so we subtract 1 from the power. And then you have to take derivative of what's inside, and derivative of what's inside is -1. This -1 and this -1 become a +1. And so you're left with that, which is the original thing, all right? That makes sense? You don't have to check every problem. I would say on the first test you could. Later on, it becomes too difficult to check because it takes you 20 minutes to check it because it's such a nasty function. Not 20 minutes, maybe 5 minutes. All right. Okay, so far things look okay, at least, I think. Y'all doing all right with this?
I just had a random question.
Yep.
So what if the question you start out with is like a second or third derivative, and it wants us to go all the way back up to the first function? Will there be something like that on the test where it's like, you know, the second derivative is equal to 0 equals whatever, you know, something like that? That makes sense.
I'm not quite sure if you're asking me, like the questions from the homework where you start out with like the acceleration and then you go back.
Yeah, yes, something like that, but with this integration.
Yeah, I mean, we won't use this notation. It'll be like, hey, here's the acceleration function, or here's the second derivative, go back and get me the original function.
So there's no way, well, no, isn't there like a notation that you put on the integrand for like first and second antiderivatives or something like that?
For antiderivatives?
Yeah, like going backwards, isn't there some notation?
That's
to
a
like,
great question. That's a great question, and the answer is no. Like if we wanted to do, okay, so like for example, if I gave you a function f of x and I wanted you to take the first derivative, right? It's just a prime mark. If I want the second derivative, I do 2 prime marks. If I want the 8th derivative, I do an 8 in parentheses, right? That's the way you notate derivatives. So what you're asking is if I want to give you a function and I want you to go and do the antiderivative like 3 times, right? There's no notation for that. There's not. All you could do, all you would be able to do is this: integral of the integral of the integral of f of x dx. You could do that. So you're like, find the antiderivative, then find the antiderivative of that, and then find the antiderivative of that. You could do that, but there's no like quick notation. The thing that's dangerous about this is you have this notation, and that's not the same thing. Okay, so these two are not the same. This is called a triple integral, and you're actually your function lives in 3-dimensional space.
Okay.
Okay, so it's different. You have a function that's not just a function of x, it's a function of x, y, and z, and so these two things are not the same.
Okay.
Okay.
And that's calculus 3, right?
Yes, triple integrals are in Cal 3. Okay. All right. So here we go. Same sort of thing. Like, there's nothing obvious, but you can't just do the antiderivative using any like power rule or anything like that right now. So let's go with our next contestant. Is it Collins? Is Collins here?
Yes, sir.
Hey, Collins. Oh, by the way, if I call on you and you go by a different name, let me know, because I can adjust it here when I call on you. So Collins, you basically have to take a shot here at something. Like you've got to try something. So go. Can you just think of anything that you want to be your something?
7x plus 9.
Okay, so 7x plus 9. Does that seem reasonable to everyone to just go with that? All right.
Yes.
Collins, what would the derivative of this be?
7, sir.
7. Okay, now I'm going to bring the dx over. Is everyone clear that I would have had du over dx and then I just bring the dx to the other side? Just multiply it, right?
Yeah.
So I'm going to stop writing du over dx. From now, I'm just going to do du and then equals the derivative, and I'm going to slap the dx on the other side just to save myself some time. Okay, Collins, let's match things up. Everything under the radical you've got. You're going to call that u. But what are you going to have to do to get the other parts to match? So you want a dx here, but you actually have 7 dx's.
Oh, multiply by 7, right?
Okay, so if I multiply both sides of this equation here by 7, then I'm going to get 7 du equals 49 dx. Is that what you want? You're on the right track, but it's not multiply by 7.
Divide?
Divide by 7, right? So let's divide both sides by 7. I'm going to do a kind of slightly different language. I'm going to multiply both sides by 1/7. Okay, I'm going to multiply both sides by 1/7. Does everyone see that this in blue here did not match with what I had in blue over there? So I'm trying to get it to match. Now it does. Colin, does that make sense?
Yes, sir.
Okay, now at this point, Collins, you should be able to rewrite the integral. So let's see what it would become. Integral, and then go ahead, you tell me.
Of square root u divided by 7.
Okay, and then divided by 7. How about we pop that as a 1/7 on the outside? You okay with that?
Yes, sir.
Okay, now don't forget, there's also a du, right?
Yes, sir.
Okay, so we just basically put that whole thing went in here, but we got that 1/7 out of there. Okay, so Collins, how are you going to go about finding the antiderivative of this?
Oh, don't we have to add 1 to the square root or whatever? To like
Yeah, okay, so power rule, right? But let's first rewrite it as u to the half.
Yes, sir.
Okay, and then you can use your power rule where you add 1 and do all that stuff, right?
Mhm.
Okay, so I'm going to save us all some time. assuming that you know how to add 1 and then get your fractions together, this should come out to be 2/3 u to the 3/2. So I'm skipping some steps there. Right? I had to do 1 over 1/2 plus 1, u to the 1/2 plus 1, and 1 plus 1/2 is 3/2, and yeah.
Sir, from the very beginning, could we have rewritten it as 7x plus 9 to the half power?
You could have. Mhm.
Okay.
Yep. There we go. And then, of course, we could check it if we wanted to. Any questions on that?
So just to be super clear, whenever we do their substitution and there's like a coefficient or something with the dx, we have to get rid of it.
Well, yes and no. I mean, we just need it to match. Okay, so in this problem and the previous one, we had to do something. We had to do something over here on that line, right? Or actually that line, to kind of make the dx be just dx, right? Mm-hmm. So here we divide both sides by 7. In the previous one, we multiplied by -1. You just always want to be able to match. And you want to be able to replace what's in the integrand with something that's in terms of u. All right, so let's do some more. You're going to see that we're doing this like constant game of trying to make things look identical, right? Let's just do a couple more, and I think it'll just start to become more and more clear, hopefully. And you don't always have to do it. You only have to do it if it doesn't match up. So let's see. Let's see this one. All right. We are to, is it Aisha or Aisha? No, I see you. I see, I don't even know. Askar, last name Askar? I see you here, but you're not responding. No, last call. Okay, Sydney Williams.
Right here.
All right, how you doing, Sydney?
Doing good. If you hear a dog whine in the background, just ignore it. My dog wants attention. I can't right now.
Yeah, okay, I understand. Or your dog doesn't
Oh,
like.
Aisha's saying that her microphone doesn't work.
Oh, okay. All right. Well.
No.
Is that in the chat?
No. Sorry.
Okay. Yeah. Gotcha. All right. I see that in the chat, Aisha. All right. So Sydney, you were saying your dog doesn't like listening to calculus or something like that.
Okay. No. He's just moving around trying to get my attention.
All right. So here you go. This one looks pretty ugly, doesn't it?
It does. Please stop.
Okay, but don't freak out. I mean, just look for something in its derivative.
I would say probably use 1 plus x to the 4th as a u sum.
Okay. I agree. What's the derivative of that?
4 multiplied by x to the 3rd.
Okay, and then I'm going to slap the dx there, all right? So when you pick your u substitution, it's not just like a completely blind, like I'm just going to pick something. There should be some thought to it. And I think Sydney had the right idea here, because Sydney, would I be correct to say that you were thinking the derivative of 1 plus x to the 4th, you had already like mentally thought about what that derivative is?
Yeah, I just saw like what could be derived to get one of the two factors, like what you gave in the notes earlier, and x to the 4th gave x to the 3rd. So
yeah, exactly.
Yeah.
So you know that when you take derivative of x to the 4th, it's gonna wind up being an x to the 3rd, right? We don't care about the constants so much. Now, just to put it out here, what if Sydney had said, let's just do the x cubed, okay, as our u?
oh my gosh.
And the derivative of this would have been 3x squared dx. And the problem with that is that I don't see 3x squared. You know, like it's not there. I see you know, here in this case, x cubed would be this piece, and then anything x squared in it would have to come from that, and that's trapped in a parentheses. It's in the denominator. You don't ever want that du to be in the denominator. You don't ever want it to be trapped in a parentheses or a root or anything like that. So it's not just completely blind picking here. There's a little thought to it. Okay, but this is good. So Sydney, let's continue here. We're going to be able to replace the 1 plus x to the 4th, right? That's going to be our u. There's a perfect match there. Now what you need to do is see if you can't get everything else. That means the x cubed dx to match up with what you have over here. And you're off, right?
Yep.
You're off by 4. So what are you going to do?
Multiply the initial by 1/4.
Yep, we're just going to multiply both sides of this equation by 1/4.
Stop it.
And now it matches perfectly. That's going to become that. This is going to become that. All right, Sydney, let's try and finish this up. We have an integral. You go ahead and tell me what you want me to write now.
All right. Stop. Sorry.
All right.
So you put 1/4 in front of, I forgot what that sign's name, what that
The
symbol's name
integral
is.
sign. That's
Yeah,
fine.
the integral sign. And then x, oh, and then, yeah, x/3 over u.
X to a 3rd over u. Is that what you're saying?
Yeah, over u to the 1/3 power.
It might help if I write this. Here's the original problem. I'm going to write it in a slightly different manner. Okay, so by doing it this way, it might help you in the rewriting of it. So the x cubed dx got replaced with 1/4 du, right? The blue?
Oh, yep.
Right, so you took care of the 1/4. I'm going to slap the du on the outside, or the back of it. And then what is all this stuff? How is that going to be rewritten?
So then that would be 1/u to the 1/3 power.
There you go, 1/u to the 1/3. And that we can do with the power rule, right?
Right.
That we can say this is the same as 1/4 integral. Now we have to bring the u up as a negative exponent because the power rule only works when your variable is up on top. And then you just run through your power rule, right? We're going to do 1/n plus 1, u to the n plus 1. And let me move on here. We'll put someone else on the spot now. How about Chris A? Is Chris here? I don't see Chris. No Chris? Missing out on all the fun. Okay, how about Kelsey? Kelsey? There you are, Kelsey. Okay, so Kelsey, I kind of right in the middle of the problem. I'm putting you on the spot here. So power rule on this, are you comfortable with power rule on this one? There you go.
So it would be,
Oh, get rid of that integral sign. I can go slow. 1/,
1/, -1/3 minus 1.
no,
Oh,
plus 1, and then u to the same thing, right?
Right.
And then very important, the plus c, right?
Yes.
Okay, so -1/3 plus 1 is 2/3. And then you have the reciprocal of that, so that's going to be 3/2. So 1/4 times 3/2, u to the 2/3 plus some constant. And then I'll clean that up. That's 3/8 u, but u was 1 plus x to the 4th. All of that raised to the 2/3 plus some constant. And of course, we could check.
Out of curiosity, on the test, if we forget to convert the U back to the property, we take points off.
It wouldn't be completely correct, I guess. It would be like, me asking you what your favorite car is and you tell me blue. Because we're asking for the antiderivative of a function with respect to x, and your answer is in terms of u.
Mm-hmm.
And I never even asked you anything about u, right? So technically it wouldn't be completely correct. Now, am I going to dock you big time points? No, you're just getting into this whole idea. So I just, 9 out of 10 points, let's say you would get, right?
Okay.
Same thing if you forget the plus c. If you forget the plus c, I can't give you full credit. In fact, there are some professors out there that if you forget c, they'll just count it all wrong.
Mm.
I'm not that way, but on the first test, I will take off 1 point, but if you continue on the other test to forget the plus c, I'll start taking off more each test.
Okay. Sounds
Okay.
fair.
Yep. Okay. So far, these problems are you starting to get a little bit of a rhythm going here with what's going on? These are all still very basic at this point. All right, next up is it Uriel? Uriel?
Yes.
Am I saying that right?
Yes.
I'm trying
Uriel.
to. Uriel. Okay. All right. What do you got here?
How about making U equal to 5x plus 2?
Okay. Sounds good. The derivative of that would be
5dx.
5dx. Okay. Now here's where I start to kind of match things up. That little thing here, the exponent, 5x plus 2, that's going to be my u. Okay. So if you're like kind of thinking like, what is my new integral going to look like? Like right now, just mentally, I'm thinking that's my new integral so far, right? It's going to be e to the u. But then I have to worry about this dx. I've got dx there, but I got a 5. So Uriel, what am I going to do?
Divide the 5.
Yeah. You said divide by 5?
Yes.
Okay, so I'm going to just do 1/5 du equals dx. Now I have a perfect match. That matches. That matches. Okay, so what's the new integral?
Would be 1/5 the integral e to the u du.
E to the u du. Good. See, and notice everyone, we're not forgetting the 1/5 came out, yes, but we are not forgetting the du, right? The du is also there. And now, Uriel, what's the antiderivative of e to the u with respect to u?
Should be was e to the u. No. Oh man.
In case y'all forget, remember this formula sheet right here, formula number 4.
It is e to the u.
It's itself, right? So this is that
itself.
special one. So it's just going to be e to the u plus c. And now we just replace your u, right, with what it was, which is 5x plus 2 plus c. There we go. All right. CJ? CJ around? Oh yeah, there you are, CJ.
Give me 1 second to write it down.
Yep. Yeah, take your time.
Okay, so all I really have is the cosine 3x.
Okay. So do you want u to be the cosine 3x?
Yes.
Okay, let's go for that. I was actually really hoping that's what you would pick.
Then the derivative would be sine 3x.
Negative sine
Negative sine 3x times 3.
times 3 dx. Everyone agree with that? If we make that substitution, that's what we get. Now let's see if this is going to work. Cosine of 3x is your u, right? That's your u. Uh-oh. Okay, so we need a 4 dx. That's the only other part. Over here, we've got a dx. We don't have a 4, but I think we could make a 4. We could make a 4 by, it would be kind of clever, but we could just multiply by 4/3 here and 4/3 here. The 3's would cancel. Do you see how that would make a 4 appear? But what's the problem though? We have a problem. All of this.
The
What am I
4.
going to do with all that? Right? What am I going to do with all that? That's appearing here, but it's nowhere in here, right? Like I don't have anything with sine in it at all. So remember, when you pick your something, you must also see its derivative, right? And even though I do see this, yes, that is a something, its derivative with that sign, it's off by more than just a constant. It's off by an entire function. Does that make sense?
Mm-hmm.
So CJ, this is a point where you would do this. And you would start over with a new u. So I was really hoping you would pick that because so far everyone's picked the right u. So there's no learning unless you make the mistakes first. You have to make mistakes. You have to pick the wrong thing. That way you see, okay, now just try something different.
Mm-hmm.
So CJ, let's go with a different u. Something and its derivative.
The 3x.
3x, okay, let's just go with the 3x. It seems like that's a ridiculous substitution to make, but let's see. This becomes just 3dx. So do you see, CJ, now we have u, yeah, sorry, I highlighted the wrong thing.
That'd just be the cosine u.
Yeah, it's gonna turn into a cosine u. Now we do have 3x, 3dx, but up here we have 4. So I'm just going to do the same thing we did a second ago. I'm going to go 4/3 here, 4/3 here. And what that gives me is 4/3 du equals the 3's cancel, 4 dx. And now I have a perfect match.
Mm-hmm.
What about the 4 in front of the dx?
Right? Well, that's how I just took care of that by coming in with this 4/3.
No, like after that step, like 4/3 du equals 4 dx. Like
This right here?
Yeah.
What about it?
So is it just we're gonna leave it because we're just off by one constant?
Well, I'm leaving it because let's just rewrite the original problem. Do you agree that the original problem is really this? All I did was just slid that 4 right there. Yeah.
Oh, I see now, yes.
So now this matches exactly with that. So CJ, what do we got here in this new integral?
4/3 integral cosine u times du.
Times du. Okay, good. Now we got it to something we can manage. What's the antiderivative of cosine of u with respect to u? So antiderivative, not derivative, right?
Mm-hmm.
So 4/3 Sine.
times sine u plus c.
Plus c, good. And then one more step.
And then just 4/3 cosine. No, sine 3x.
There you go. Plus c. Perfect. There you go. All right. So the first 6 problems were all very much just pick a u. All right. du's there. We might have to tweak it a little bit, right? Tweak the constant. But otherwise, those are pretty straightforward, I think. I know for you, you're just learning this, so, you know, it's the first time you've seen them. And okay, how about this? These are going to get more and more interesting. How about Ben?
So if we choose, Professor, if we choose to push this to next week, we will have this on the test, correct?
Oh, this is on the test anyway.
Okay.
Yeah. Yeah. Yeah, the question is whether or not this is the only thing on the test. We haven't talked about integration by parts yet. We may not even get to integration by parts. Because the way I'm doing this, I'm asking everyone, I'm trying to get participation, I'm trying to get everyone active, and that does slow us down.
Mm-hmm.
But I think it's worth it. All right, so Ben?
Yes, sir.
Ben here? All right, Ben. Have y'all heard that phrase, you know, you can't win the lottery if you don't play it, right? Y'all heard that? Like, you can't win $1 million if you don't play the lottery. You can't hit a home run if you don't swing the bat. You know, this is where we are. You have to be willing to swing the bat here. And like CJ was perfect. That's what I wanted to see. I want to see someone take a swing and say, oh, that's not going to work. Okay, we try something else. But we don't want to say, oh, that didn't work. Why do I want to be an engineer? You know, we don't want that. Persistence. All right, Ben, you're up.
All right. I say the U would be ln x.
Okay, can you tell me why you're thinking that?
It's just going to be 1 over x.
Because the derivative of that is 1 over x. Do you see 1 over x there, Ben?
No, but you can manipulate it, right?
Yeah, so you do see it. Here's what Ben is realizing, I think, is that the whole thing over x is the same as having a 1 over x off to the side, right, Ben?
Yeah.
Yeah, so you saw that. You saw all of that. When you picked your u, you already saw all that in your mind, right?
Mm-hmm.
Okay, that's good. That's what you want to get to. You want to get to a point where you're seeing all that. Does anyone have a question on that choice of u? We have a u, that's our something. We see its derivative, 1 over x dx. I think everything's going to match up really nice here, right? Like you don't have to do any work. Natural log, 1 over x dx, 1 over x dx. We don't have to multiply by 4 or divide by 7 or anything like that. So Ben, what do you got? What's your new integral?
It's going to be sine u.
Just sine u.
Or, yeah, sine u.
Sine u.
Over
du.
d and du, yeah.
Sine u du. Everything just got swapped out. The yellow and the blue got switched out.
Mm-hmm.
And then Ben, the antiderivative of sine of u is
going to be, I think it's negative cosine.
Negative cosine of u.
U.
Plus c. But u is actually natural log of x.
Okay.
Right?
Yeah.
So we just got that one additional step where we just replace our u. Good job. That was good.
Thank you.
All of y'all have done great. This is good. I hope it's constructive for all of you in the class. And it's fun to do problems that I haven't. Well, I mean, I've seen variations of these problems, but it's always fun for me to do stuff I haven't done. Oh shit, this one looks very well. I see it now. It's not bad. Initially though, my first like reaction to this was like, crap, are we ready for this yet? It's tricky. All right, so our next contestant is it Sumit? I don't think Sumit's here. Well, Sumit's here, but Sumit has not responded. The last time I called. So this is what I'm talking about. This is participation right here. So if I call on you, you're not there, consistently not there, then I don't care if you're showing up on my Zoom. I'm taking it like you're not here, okay? All right, so we're moving on to Sergio.
Yes.
Sergio? All right, Sergio. All right, you're up to bat, like figuratively here. You're up to bat. So you gotta take a swing here.
Yes. I think maybe you will be x to the 2 x squared plus 4x minus 3.
So you're just gonna take the whole denominator, right?
Yes.
Okay, that seems reasonable. It seems odd to pick so much stuff, but let's just go for it. The derivative of this, Sergio, is?
Would be 1 plus. So give me a second.
I think you might be ahead of me on that, but the derivative of x squared plus 4x minus 3 should just be 2x plus 4. Does everyone agree?
Mm-hmm.
Okay, now, Sergio, do you see that somewhere? Do you see 2x plus 4?
Not really.
Not really, but you said not really.
It's on the top, right? Because it's off by a what is it? A constant.
Yes.
Maybe we like manipulate it.
Exactly.
Exactly, but it's not exactly there.
Let's see, Sergio, what could I do? Let me rewrite this just so everyone sees this. Sergio, what could I do to make the 3x plus 6? What could I do over here to make it match up with this? Because right now it's not the same.
Mm-hmm.
So do you have any ideas? You're only allowed to like multiply or divide by a number. So
Maybe like divide by a third.
Divide by a third. We're gonna work with this.
Multiply by a third.
Okay, multiply by 3. So we can multiply this side by 3, multiply this side by 3. Let's just do that and see what we get. We distribute the 3 through.
Should just multiply it all by 3 halves, right?
Yes, I'm shaking my head, whoever said that.
Okay.
So there, Sergio, I multiplied everything by 3, so we're a little closer.
Yes, what I was saying was divide everything by a third. Like multiply everything by 1/3.
By 1/3?
No, it wouldn't work. No,
yeah.
I have a question.
Hold on. We're gonna get to it. I'm trying to get a 3 and a 6 over here.
Yeah, you can multiply that one by a half.
A half. There we go. So essentially, what we're doing is we're really at the end of the day multiplying both sides by 3 halves. So I'm gonna divide by 2 here and divide by 2 here. You get 3 halves du.
Okay, then it wasn't
equals 3x plus 6 dx. Now, whoever had the question, go ahead.
Yes, so my question was, is there any way, like, for example, can I multiply or divide with the whole expression?
Where, oh, you mean this expression, the original integral?
Yes, like if I use 3x plus 6 over 2x plus 4, like, and I multiply it on both sides.
There is no both sides. This is a good question. When you have an integral, right, you are looking at an expression. So you are not allowed to multiply both sides of it by anything because you don't have sides. You just have an expression. So the only thing you could do is multiply the top and bottom by 2x plus 4, like a hidden 1.
Not even if I'm trying to multiply on the sides, like where it's du and dx, when I'm trying to substitute.
I'm not quite sure if I follow.
So instead of using the 2 there, can I use 2x plus 4 over 3x plus 6 and multiply it on the both sides?
Are we talking about this over here? On the right only?
Yes.
Okay, so which line do you want to look at? The second line, third line, fourth line?
I like the second one.
Okay, so start out here. Now you're asking me, can you do what?
So like, in order to get the 3x plus 6, can I multiply 3x plus 6? Oh, so 3x plus 6 over 2x plus 4 on both sides. So that will
3x
cancel the
plus
2x.
6 over 2x plus 4. Multiply that on both sides. 3x plus 6 over 2x plus 4. Like that?
Mm-hmm.
Okay, so what would happen is it would go like this. Yes?
Mm-hmm.
Okay.
And then we have like the dx. Can we just equate the du then that way?
Okay, so what you would be saying then is you want to replace everything in blue here with that, right? So
Yes.
you're going to replace that with this.
Yes.
My answer is yes, you could do that, but I don't recommend it. And here's why. Do you see that what's in yellow has X's and U's mixed together still? You see how U's and X's still together? Now,
Yes.
it will work. It will actually work. But when you get U's and X's mixed together, it becomes potentially a disaster. Because the whole idea is to get the integral in terms of U, not in terms of X still. And so that thing in yellow is still going to have stuff you have to deal with. That make sense?
Yes.
Okay. So I prefer to just look at it as this line right here, when we're right here, just to say, okay, how can I make those match? Now, let me show you another slightly different approach that could have worked also. Watch. At this point right here in the very beginning, when I said, look, this is not matching with this, I could have factored a 3 out of the integral. Okay, so I just took a 3 out of the top, right? And then over here on the right-hand side, I could have realized that I could have pulled a 2 out. You see how I pulled a 2 out of that? And do you see that this now matches with that? I just need to get rid of the 2, so I do a half here and a half here. They cancel, and so I'm going to be replacing it with a half du. And then when that half comes out, I wind up with 3 halves. So it's the same thing we just did a second ago, just showing you a slightly different approach. Now, I never finished the damn problem. Sorry. Okay, here's where we are. We have u is 3x plus 6. No, that's du.
X squared plus.
Yeah, I'm not going to even put that there. U is the x squared part, blah, blah, blah. And then we wound up doing 3 halves du equals, and when we multiplied it, no, not 3 halves. Was it 3 halves?
Yeah, it was 3 halves, so we get that 3x plus 6 dx.
Plus 4, that's what it was. Okay, so then we wind up with our 3x plus 6. Okay. Okay, that's where we were. So now when we rewrite this integral, Sergio, do you want to take over again, or?
Yes, I can try.
What's that?
Yes, I can try.
Okay, go ahead.
Okay, so it will be integral
Mm-hmm.
3x, give me 1 second. So if you move the dx to the other side, right, that's what you have to do, right? On the, wait, no. Yes, maybe rewrite 3x to plus 6.
So look, this part right here is getting replaced with u, right?
By you. Yes.
Okay, so that's just going to be 1 over u.
Okay, so
And
it's just
then
1 on the top.
this, right, is getting replaced with what?
3/2. Yes, 3/2 d2. Du, sorry. 3/2
There
du.
you go. Yeah, and I pulled that 3/2 outside.
Yeah,
Okay.
yes.
Now, do you know the antiderivative of 1 over u?
1 over u will just be like u to the negative 1.
So, okay, so that's really u to the negative 1.
Natural
But
log.
remember, Sergio, this is that special case. You can't use the power rule on this one because it's negative 1.
Okay, so
Use a natural log view of absolute
Formula
value.
3 here. Whenever we have just like 1 over u,
okay, the natural log.
natural
Well,
log u plus c,
See.
and then 3/2 natural log of u, but u was that whole big thing, right?
X, yeah, x squared plus 4x minus 3.
And then plus c. There we go. That's it.
Okay.
Would it be wrong if the second to last step, when you're doing the integral 1 over u, could you put the du over u, or would that be like?
Yeah, you could. Yep,
Doesn't
that
matter?
would be okay. That notation is the same. So this could have been du over u, like that. That's the same thing.
Cool.
Now, also, I need to put absolute value here. Sorry, absolute value. Because the antiderivative of 1 over u is natural log of u, or natural log of the absolute value of u. All right, so that one was, you know, yeah. Okay. I think it's Rania. Rania, am I saying that right?
Yeah.
Quick question about that last one.
Yes.
Could you have factored both the numerator and the denominator beforehand? And then got the same thing? Yeah.
The denominator was unfactorable.
It was factorable. Okay, never mind.
Yeah, I don't think this would factor, but you know what? Guess what? Later on, we will deal with things that are factorable, and that'll be, well, it won't be fun. Well, it'll be fun, but it'll be much more involved. We'll have to use partial fraction decomposition. And part of the problem will be to try and get it back to something like this. Like it'll be like, hopefully it'll look like this at one point, but. Okay, here we go. And it's Rania is up.
Yes.
Take a swing. What do you got?
U equals x squared plus 1.
Good. Du is?
The
What's derivative of x squared plus 1?
1. Or x.
2x.
Yeah, take derivative of x squared, power comes down, right? So 2x. And then that's it, right? Then dx. Because the derivative of 1 is 0. All right, Rania, so I think we've got this. This is x squared plus 1 is going to be the u. And then we don't quite have, we have an x dx, right? Here we have 2x dx, so that should be pretty easy to get rid of that 2, right?
Yes.
Just hit both sides with a half. And that'll get you the dx that you need. Or sorry, the x dx that you need.
Yeah.
So this should become, go ahead, Ronya, you can tell me what the new integral is. I know I'm moving a little quick here.
It's gonna be 1/2,
Okay.
and then the integral sign,
Mm-hmm.
and then
Oh, what was that?
and then it's gonna be 3 to the u.
Yep, 3 to the u. And then what does the x dx turn into? You already have the 1/2, right?
It's gonna be du.
Yeah, du. Okay, so now we need the antiderivative of 3 to the u. So for those of you who don't remember, you go back to your formulas. This is formula 5. Why is that not writing? That's really weird. Interesting. Okay. Formula 5, antiderivative of a to the u, du is a to the u over natural log of a, plus a constant. So this should be 3 to the u over natural log of 3 plus a constant, which is going to be 3 to the x squared plus 1, that's u, over, I'm going to put the 2 next to the natural log of 3 in the denominator, and I'm done. I'll put that back up in a second. I want to go grab another one. Trying to decide which one I want here. None of those look very interesting to me. Here we go. This is more like it. Okay, I'm gonna let y'all think about this. I'm just gonna go refill my drink. And the next person up is Cameron. So Cameron's going to hopefully help us out here. Oh. I'll be back. Hey, Coral. Are you done? I said 1:30. I forgot. I think I said 2:40. And our thing is ready at 1:30. It's ready. Okay, maybe you can go just get it. Okay, y'all there? Cameron? Is Cameron around?
I'm right here. What's up?
Oh, there you are. Okay, yep. All right, so yeah. I'll give you a kind of heads up. This problem is different.
I think I got it. I think.
Okay.
It also might be totally wrong.
What did you do?
So I set u equal to x minus 1.
Okay.
And then, you know, du equals 1 to the dx, because that's the derivative of that. And then I multiplied it by the whole thing by x plus 3 to get x plus 3 dx. And then
See, okay, I see what you did. Yes.
I don't think that's right.
You're going to get hung up at that point. So let's follow Cameron's logic here. You picked x minus 1 as u. That seems fair. You took a swing. The derivative of that, du is dx, right? You have that there. But Cameron has a problem. This x plus 3 is not taken care of. And we're off by more than just a constant, aren't we? Like I can't multiply the left and right hand side here. I can't multiply by something like just a number that's going to make that x plus 3 appear. Does everyone see that? We're off by more than a constant. We're off by x plus 3. And x isn't a constant. Go with me? But there's something special about this problem. This is an equation, right? And so I know you're not going to like this, but
are we gonna real quick? I just want to see if I'm thinking about this properly. Since we you could go either way with that u if you wanted to pick x plus 3 and x minus 1, but we run into the problem of not being able to turn that 1 dx into the other solution. So are we basically going to manipulate u to have 2 u's for each one, or no?
We're going to manipulate that first equation to make an x plus 3 appear.
Okay, all right.
Okay, so yes and no. We're kind of on, you're kind of on the same right track. So look at that equation, u equals x minus 1. Would you agree that if I add 4 to both sides, I would get u plus 4 equals what?
X plus 3.
X plus 3, right? So now don't I have an expression for x plus 3 that's in terms of u?
Yes.
Yes?
I didn't get that. That confused me.
Yeah, it should be. It should be a little confusing here. So I'm backing the whole ship up. Okay, so hold on. Cameron made a substitution. U is equal to x minus 1. The derivative of that is just 1 dx. So when we look at this expression, the x plus 1 matches. Okay, so that's u to the 5th power. So in my new integral, I know I've got a u to the 5th power in there. But now we're trying to figure out this dx and this x plus 3. The problem is I've got dx, but I can't make an x plus 3 appear because I already told you, you can only be off by a constant, and we're off by x plus 3. But if I'm saying that u equals x plus 1, we're saying that that's true, right?
Okay, I see.
And I really want to have an expression for x plus 3, then if I'm clever, I can add 4 to both sides of that equation, and that will make an x plus 3 appear. You see? So I take that, I add 4 here, I add 4 here, and now I have x plus 3 represented as something in terms of u. So if I now rewrite the problem, so Cameron, how would this rewrite then? What are we replacing x plus 3 with?
U plus 4.
U plus 4 in parentheses, right?
Yes.
Okay, and then what are we replacing the x minus 1 to the 5th with?
U to the 5th? No.
Yep.
Yeah.
U to the 5th. And then what are you replacing dx with?
Du.
Du. All right. Now, do you see what you can do here, Cameron?
The chain rule, or the opposite of the chain rule, power rule, sorry.
Power rule, okay, but first you've got to do just some algebra. Multiply that u to the 5th through. U to the 6th plus 4u to the 5th. That removes the product and just creates that expression. I totally messed up. My wife had put together an HEB order for me to pick up today. I told her 1:30. For some reason I thought, I don't know. What happens when you don't show up?
They put it back.
They just put, you gotta reorder it. Like they just
Really?
don't, they put it back. Like once, I think for any pickup, like once you pass an hour, I think they give you like an hour window. And then you can just like replace your order, but I'm not sure what really.
Yeah, I'm gonna just tell them we'll be there soon. Okay. All right, so now at this point you can use power rule, okay? This is just gonna be 1/7 u to the 7 plus 1/6 u to the 6th plus c. This problem is different than anything we've done so far.
But there's a 4, right, on the
Yeah,
YouTube
there's a
fifth?
4.
Oh, there's a 4. Yeah, I forgot the 4. Thank you. Forgot the 4. So now we have to replace u. So 1/7 x minus 1 to the 7 plus 2/3 times x minus 1 to the 6th plus c. That's tricky. Get used to it though. Now, Cameron picked x minus 1 to be the u. Would this have worked if we did the x plus 3 as the u?
I think so, yeah. I was working.
Maybe? Let's
like
try
that.
it. Let's try it. Because guess what? It doesn't. Okay? So
Doesn't
let's
the exponent mess
see
with the, you have to factor out the entire exponent, wouldn't you?
Yeah, so that's what would cause a problem. Let's see. If we were to have done, instead of that, let's do x plus 3. Then du would still be dx. So we would have x plus 3 taken care of. We would have du is dx, that's good. Except now we'd have to figure out if we can find a way to express x minus 1. So we take this expression, what would we do to both sides to make an x minus 1 appear?
U minus 4.
Subtract 4 on both sides. Right? So now we have an expression for x minus 1 in terms of u. So we rewrite it. Everything looks like it's working so far. This x plus 3 becomes u. And then what is all this? X minus 1?
U minus 4 to the
That's u minus 4 to the what?
5th.
5th power, and then du. So the reason why I'm saying this wouldn't work is because you could not at this point pass the u through. You can't do that because you have a 5th power here. So you'd actually have to expand out u minus 4 times itself 5 times. Now you could do that, like algebraically it could be done, but it doesn't work as easy as the last one because on the last one, doing it the other way, see on this step right here, we had u plus 4, you know, there was no power on that. And so we were able to distribute the u to the 5th through. But on this one, you can't. You have to do all of that first. And so if that was like a 50th power, then again, you would just give up. You wouldn't want to do it that way. Much more interesting problem.
So I guess that would be another tip, right? To look for the highest exponent and see if we can tweak it.
Yeah. I don't even know. Let's. Let's do this one. All right. Okay, so, you know, we're still doing substitution here. I think I'm going to make a call here on the test. Let's postpone the test. Let's do it on Tuesday, a week from today. All right. And the reason is because we're not even going to really finish substitution, right? This first test needs to have at least substitution on it. So that way we can get through substitution. We can do integration by parts, at least the first part of integration by parts on Thursday, and then you have the whole weekend to get ready for the test. Okay? I think that'll work out better. I don't want to rush this first test, but I'm also wanting to take my time through this. So let's do that. That way there's no pressure for me to talk about the test right now and all that. We'll talk about it on Thursday.
And what's 6.1?
Integration by parts, which we have not started. Okay, here we go. Who's up? Cameron just went, thank you. How about Omar? Omar?
Yes, sir.
Okay.
Can we do x squared plus 4 as the u?
Yes, you can. So I have a question, Omar. Are you mentally prepared to swing and miss?
Yes, sir.
Are you gonna handle that okay if it happens? All right.
Yes, sir. I'll try to keep
I'm not sure
ego intact.
All right. Yeah, I don't know if this is gonna work or not.
Okay.
Let's see. So now the derivative of this is
2x.
2x, and then we got dx. Okay. So do you see that derivative somewhere?
No, sir, I don't.
Not really, right? Like you do have an x down here, right? You do have an x on, but see, it's on the bottom, and you're never allowed to have that derivative on the bottom. So this isn't looking very promising. We do have a dx matching here, but that whole denominator is just throwing everything off. Do you agree, Omar?
Yes, sir. So you say that we can't have a derivative on the bottom?
You cannot have your du part cannot appear in the denominator. So like, let's say this original problem, let's say it was this, just exactly this. That wouldn't work, okay? Because even though this dx matches, 2x matches, it's in the denominator.
Okay.
Okay? All right, so I think you need to step back up to the plate.
Is it possible to like factor out the x squared plus 4 to x plus 2 times x minus 2? No.
If it was a minus, you could do that, but it's not. It's a plus, right? This is a sum of squares, not a difference of squares, so it does not factor. Yeah, had that been an x squared minus 4, then I'd say break it up, cancel, you'd be in business. All right, Omar.
So now we'll try x plus 2 as a u.
Yeah, why not? Let's go with it. X plus 2. All right. So let's see.
1.
Yep, is 1 dx. Okay. So far, Omar, you can replace the x plus 2 with u. You can replace the dx with du. That's not so bad. But now you have all this crap up here, x squared plus 4, which you have not accounted for in any way, right?
No.
Can you, though? You just need to somehow make x squared plus 4 be something that has u's in it instead of x's.
And u squared?
Hold on, I want Omar to think through this. Do you know what x is, Omar? Like,
I'm sorry?
Can you tell me what x is in terms of u? What's x?
I'm not sure I'm like understanding the question.
Okay, so see what I pointed out here?
Yeah.
If I ask you what x is, can you tell me what x is in terms of u? Can you solve that for x?
Yeah, u is, x is, like u is x plus 2.
U is x plus 2, but if you solve for x, subtract 2 on
U
both sides.
minus 2.
Okay. All right, so you can tell me what x is then, right? So can you tell me what x squared would be? Right, you see what I'm doing?
So we substitute the x with the u minus 2.
Yeah. So let's go ahead and square that. If I square that, I get u squared minus 4u plus 4. So I'm foiling that, I'm doing it in my head. Yes?
Yeah.
Okay. So now I know what x squared is. So now, Omar, let's rewrite the whole integral. The x squared gets replaced with what?
U squared minus 4u plus 4.
Okay, and then we still have to add 4 more to that, right?
Right.
So
Yeah.
that'll be u squared minus 4u plus 8, yes?
Yes, sir.
And then over, what's the denominator, Omar?
X. Is it x plus 2?
Which is what for us?
U.
U. And then what's dx?
1.
1 du, right? 1 du?
Yes.
Okay, good. This is good. This is good. Because now this problem looks like the problems that we did before we got to this section. Notice we have a single denominator in multiple numerator pieces. So can't we split this now into 3 different things?
Yeah, so it'd be u squared over u minus 4u over u plus 8 over u du.
Okay, so I already did that. I split them and then I simplified them.
Yeah.
And now we could do each one of these one by one. Okay. How are we feeling?
Pretty good.
Yeah, that's weird. I mean, we're pretty much there. This is 1/2 u squared minus 4u plus 8 natural log of the absolute value of u plus c. So I went ahead and did the antiderivative. Now I skipped a part. We still have to replace the u's here. Do you see how this is becoming a little bit less natural and a little bit more effort is being required to do this? Like we're having to think a little more outside the box now?
Yeah.
Okay. So Omar started with the substitution, x squared plus 4. That was the first one he tried. Didn't really work. I think we all saw that. Here went with x plus 2. Didn't seem like it was going anywhere, but we could use our information about x to go ahead and figure out how to replace that x squared. Any questions? I see a lot of you like gazing at your screen, so I'm not sure if that's just elation or...
The plus 8, how did you get that plus 8?
Okay, so remember that, I'm going to use some colors here. This x squared was this, right?
Oh,
and we still had the plus 4 here.
Mm-hmm.
So we added that to that 4 at the end to get the 8.
These little things are going to get me on the test.
Yeah. Lots of room for error here. That one was pretty interesting.
And then we just replace the u's with x plus 2?
Yeah. Was it x plus 1 or minus 1? No, x plus 2. Yeah, all these u's become x plus 2's. Okay, so in all these problems, just quick glance. This one right here looks the worst. Maybe it's not as bad as it looks, but it's also the last problem off this set that I found online. So maybe it's a good one. Let's see here. We have Celeste. Celeste?
Yes, I'm right here.
Okay. You go by Celeste? I'm seeing a different name. What would you prefer?
Oh, no. Yeah, it's Celeste. I'm just using my sister's iPad.
Okay. Okay, cool.
Sorry about that.
No, it's okay.
Sorry, I'm writing the problem down.
Yeah, no, write the problem down. I'll be honest right now. I know what I would use for you, but I'm hoping there's a way through. Like, I don't see it yet. I don't see the way through this problem yet.
Sounds like kind of a different one, but I'm just gonna
Go.
guess
Swing.
here. I would say we would use the 3 plus ln x squared.
That's what I would use too. And the reason why is because it's the thing that's being squared, right? So like,
and
this
you were
would
mentioning
eventually turn
before.
into like u squared, right? If things work out. All right, let's go with it. Okay, what's the derivative of this?
Of ln x? Oh.
Of 3 plus ln x.
There wouldn't be a derivative for 3, but the derivative of ln is that one over x? I honestly kind of forget.
Yep,
Okay.
1 over x dx.
So du would be 1 over x. Yeah.
I'm gonna let you all think about that for a moment. We only have 5 more minutes. Yes. Okay. All right, so Celeste, do you see anything?
I don't see something that fits exactly into 1 over x. So I'm not kind of sure.
Okay. Let me rewrite this. Okay, so what I did is I just like pulled everything apart.
Okay.
You see that? Okay. Celeste, we have 3 plus natural log x, that's u. We have 1 over x dx, we've got that, that's du. We are off by a constant here, 1/4. We can take care of that, can't we? We could just like, over here, we just divide both sides by 4. So that we could take care of.
Yes.
The issue here is this piece. This piece here, we don't have any, we haven't accounted for that yet.
No.
But can you do something with this, Celeste? Can you make that look like 2 minus natural log x?
Like,
so just work with it algebraically. How could you make a minus natural log x on that equation?
Do you multiply by -1?
Okay, let's do that on both sides. Okay, now what else do you need? You've got the minus natural log x. Now you need
you still need a 2.
So how are you going to make that -3 a 2? What can you do to both sides?
Would you use a fraction like what we did with the last problem?
Well, be careful, because if you do multiply on both sides, it's going to impact everything, right? Like it'll have to distribute through to everything. So don't think about multiplication, think about just addition or subtraction. What could I add or subtract to both sides?
Add 5 to the -3 to get a 2.
Yep, add 5 here. So what you get is 5 minus u equals 2 minus natural log x. And that matches exactly with what's up there, right? Okay, so Celeste, we're almost out of time here. Maybe you can help me rewrite the whole integral?
So you would put the integral sign with u square. And with the second one, you're going to put 5 minus u, correct?
Yep, in parentheses, yep.
Yes. And
We never took care of the 1/4, did we?
I don't
So
think so.
can we just pop it out to the front?
Yes.
Pop it out. Okay, just pop it out. And now
And
the
DX.
blue part. The blue part is D.
DU.
DU. There we go. Now we could distribute through.
Wait, but the 1/4 has to be included in the DU, doesn't it?
No, it doesn't have to. It can just be popped out.
Then what
You
happens
put-
to the 4 in the denominator, or the 4x?
It's not a 4x, it's just a 4 times x. So we're looking at it as a 1/4 that just comes out.
Okay.
So 5u squared minus u to the 3rd du. All right. We're there. I'm just going to say dot, 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 because you would now just use power rule on each of those. And then replace your u with 3 plus natural log x. So your homework again, right? 1 through 36. Do as many of these substitution problems as you can. There's no such thing as doing too many. Officially, the test is moved till next Tuesday. We'll come back on Thursday. We'll wrap up substitution. So I'm going to start class with any questions, maybe give you 1 or 2 more examples. And then from there, we're going to move into integration by parts.
Sounds good.
Okay?
That's great.
All right. You all have a good day. I will see you on Thursday. Thanks again for your participation.
Thank you.
Yes, sir.
Have a great day.
You too, sir. Thank you.
Have a nice day.
Thank you, sir.
All right.